Hello and welcome to today's live interactive session on geology and soil mechanics. Today we will be discussing or revising whatever was discussed in the second week of lectures. In the previous week, we discussed about the basic, we introduced the topic of soil mechanics. We discussed some basic index properties of soil, how do you calculate them, and then we solve some basic problems dealing with the index properties of soil, right? In today's session what we are going to do is that we are going to just revise the uh, soil classification topic. We are just going to recapitulate whatever was taught in the class about our soil classification, and then what we are going to do is that we are going to solve some easy problems based on that. So those soil classifications problems will be really basic and simple, but I want that you should actually uh, do it yourself. So I will be giving you the questions and the answer should actually come from your end, right? So in that way you won't have to study this topic again in the future. Today it will be like done and dusted, right? I want that you all should contribute to this so that you get a proper hold of this soil classification thing. So this is very easy, but very basic also, but all of us should know about soil classification, right? Let us start the session. Yeah. What are the objectives of soil classification? So classification means grouping, right? So to group soils which show similar behavior. So you want to assign particular groups to different types of soil so that so that they can be handled in a more easier way, right? So what does soil classification help us? Soil classification provides us with information about the probable engineering behavior of the soil. So say you know about the type of soil, you have already classified the soil. You can make a calculative guess, or you can guesstimate what kind of property or what kind of behavior that particular soil is going to have just by knowing what how the soil is classified. For example, in simple language, when I tell you the soil is sand, right? Sand, so you're classifying it as a sand, you're classifying a particular type of soil as a sand. So when I call it sand, the first thing that comes to your mind is that it's going to be loose. Say if it's on a beach, sea beach, right? So it's going to be very loose, then you can easily walk over it and so on and so forth. But when I say clay, what comes to your mind? The thing that comes to our mind is that it's going to be sticky and you cannot walk over that very easily, right? So in that way you are going to when I classify the soil, I will be guessing about, I will be knowing about some behavior of that particular soil too, right? So this is the main objective of soil classification. Okay. There are different types of soil classification system. We have the USCS classification system, which is the Unified Soil Classification System. Then we have the classification system that was given by ASTO, that is the American Association of State Highway and Transport Official System. And then we have the Indian Standard Soil Classification System. We are going to basically discuss about the Indian Standard Soil Classification System, and this soil classification system is USCS soil classification system and ISSCS soil. This both these systems are almost similar with little bit uh, a differentiation between them, but those both of them are 99% same. Okay, so if you know one, you can easily know the other one also. Okay. Yeah. Now the Indian Standard Soil Classification System, that is actually given in our IS code. It is the Indian Standard Code 1498/1970. Well, this is the code that deals with the classification of soil. Okay, so this is the code that deals with the soil classification, that defines all the parameters and everything, how you can classify different types of soil. Okay, now according to this code, there are some major soil groups in which you can differentiate or you can divide a particular soil. Okay, so all the soil type of soil that is present in this earth, that can be grouped into these major types. All right, so what are those? First we it's a gravel means very large size particle, right? The soil particle is quite large, so it is known as gravel. Then we have sand, then we have silt, then we have clay, then we have organic. So organic means the soil is formed composed of organic matter. How organic matter? Say you have trees, the leaves from the trees fall down, or trees itself they fall down, then they get decomposed, and then from that ultimately after many years soils are formed. So those are organic soil. Okay, formed out of organic content. Okay, living things, that is the organic. Then we have peat is another type of soil. So these are the major group of soils. Okay, now these major group of soils are marked with prefixes. Okay, prefixes. So when I want to classify, soil, there I will write it in a coded fashion, right? That code will have two parts. One is the prefix, and then I will have the suffix. Okay, prefix and the suffix. Okay, the first letter that I am going to write, that is going to be the prefix. And what are the possible prefixes that we can have? G for gravel, S for sand, M for silt, C for clay, O for organic, and PT for peat. So these are the different types of, different types of prefixes, possible prefixes that you can have. Okay, and then to classify the soil more in a more distinguishing manner, we are going to have one suffix too. Now those suffixes are nothing but subgroups. These subgroups are well graded, poorly graded. So whether the soil is well graded, whether the soil is poorly graded. So well graded and poorly graded, what are these things? We already discussed in the previous session, right? So what are well graded soils, what are poorly graded soils, right? Those things we discussed. Then you have whether the soil is silty, clayey, then whether the liquid limit of the soil is less than 35%, whether the liquid limit of the soil is between 35 to 50%, or whether the liquid limit of the soil is greater than 50%. Okay, in that way we are going to assign the suffixes. Okay, the suffixes are going to W for well graded, P for poorly graded, M for silty, C for clayey. For liquid limit less than 35%, we are going to assign L, that is low. For liquid limit between 35 to 50%, we are going to assign I, it is intermediate. And for liquid limit greater than 50%, we are going to assign H. Okay, H, that is high. H for high. Okay, so this is how we are going to classify the soil. Okay, this is how we are going to classify any type of soil. Now for gravel and sand. So what are gravel and what are sand? So these are coarse grained or fine grained soil. These are coarse grained soil. Right? For coarse grained soil such as gravel and sand, we can have these possible symbols. GW. Okay, GW means not we will call it well graded gravel. Then GP, poorly graded gravel. Okay, then GM, silty gravel. GC, clay gravel. Similarly for sand also, well graded sand, poorly graded sand, silty sand, or clay sand. Alright, so this is how we are going to have the classification for coarse
Plant material is in front.
yeah, we are going to have this is how we are going to have the classification for the coarse soil. Okay, now let us see for fine grained soil. Fine grained soil means clay and silt, right? Clay and silt. Now for clay and silt, let us see what we are going to have. Okay, for clay and silt, what we are going to have. So first we can have ML, that is the liquid limit is less than 35%. Okay, that is going to be silt, inorganic silt with liquid limit less than 35%. It is Ml. And Cl, again inorganic clay with liquid limit less than 35%. Then Ol, organic soil with liquid limit less than 35%. Then Mh, silt with liquid limit, inorganic silt with liquid limit greater than 55%. Similarly, Ch, OH and Pt. Okay. Now, this is the screen grab from this IS 1498. So here you can see that each of the types of soil that you are saying, the main symbol, okay, the prefixes, those are defined. When are you going to assign G for gravel? When as means how are you going to quantify this? Okay, how, what is the thing that you have to measure so that you can call a particular type of soil gravel or sand or clay or silt? Okay, this is what it is given here. Now first on the left hand side, from the on the left hand side we can see it is given for coarse grained components. Okay, for coarse grained components. So coarse grained components can be boulder, cobble, gravel and sand. Right. So for boulder and cobble there are no particular symbols, right? So let us read about gravel, from start from gravel only. Rounded to angular, bulky, hard rock particle passing 80 mm sieve but retained on 4.75 mm sieve. Right now, passing 80 mm sieve means the size is smaller than 80 mm but retained on 4.75 mm, but the size of the particles are less than 4.75 mm, right? So then what you are going to do, then we are going to call it as gravel, G. Okay, now in gravel also we have two types, coarse or fine. So if the size of the particles are between 80 to 20 mm, then we call it coarse gravel. And if the size of the particle is between 20 mm to 4.75 mm, then we call it as a fine gravel. Okay. Voice is low. I don't know. That's the maximum. Let me just open. Yeah. So similarly for sand we have, if the most of the size of the particle is smaller than 4.75 mm, but the size of the particles are greater than 75 micron, that is 0.075 mm, then we called it as a sand. Okay, if the size of the particles are lesser than 4.75 mm but greater than 75 microns, then we call this call that particle, that soil as sand. Now for sand also we can have coarse, medium and fine, and I am not repeating it again. You can see it here. Okay, then after that we have for fine grain component, fine grain components. Okay, fine grain components can be silt, clay or other organic matter. Okay, just a second. Yeah, silt, clay or other organic matter. Now silt are particles having sizes less than 75 micron. See, both clay and silt, both of them have sizes less than 75 micron. Okay. Both clay and silt, both of them have sizes less than 75 microns. But silt is generally very low plastic or non-plastic. Low plastic or not at all plastic. That way you are going to differentiate between silt and clay. If the soil is non-plastic, then it's going to be silt, and if it's plastic, definitely it will be clay. We will see that in detail in the next slides. Okay, how we can differentiate. So silt and clay both are fine grained, both have sizes less than 75 microns, but silt is non-plastic and clay is plastic. Clay exhibits plastic behavior. Okay. Okay. Now, first, as I said, how are you going to identify if a soil is first? What you do whenever you have a particular soil with you, you first try to classify it in two main groups, whether it is a fine grained soil or whether it is a coarse grained soil. First you decide this thing. You have some soil with you, First, your first task is to decide whether it is a fine grained soil or whether it is a coarse grained soil. Now, how are you going to decide whether the soil is a fine grained soil or whether the soil is a coarse grained soil? Now, if say you have 100 grams of soil, okay, say more than 50 grams of soil whatever you have, the size of the particles of more than 50 gram of soil is less than 75 micron, then that soil is majorly fine grained soil. Okay, if the soil particle size less than 75 micron, major, more than 50%, soil size is less than, soil particle size is less than 75 microns, then it is a fine grained soil, like majorly fine grained soil. Now, if most of the particle, more than 50% by weight of that soil is having particle of size greater than 75 micron, that is going to be a coarse grained soil. Okay, coarse grained soil. Now, say you have a coarse soil, that is in 100, coarse soil means what? Coarse soil, the maximum amount of that constituent soil is having sizes greater than 75 micron. That means our soil is coarse soil. Okay, now I have decided that the soil that I am having, it's a coarse soil. How did I decide that the soil that I have is a coarse soil? I decided it based on the fact that the particle size of the maximum amount of soil that I have with me, so 100 gram of soil, in 100 gram more than 50% is having particle of the soil particle, more than 50% of the soil is retained on 0.75 micron sieve. Okay, more than 50% is retained on 75 micron sieve, means more than 50% is particular sizes greater than 75 micron, right? So now you decided the soil is coarse. Okay, as soon as you decide that the soil is coarse, the prefix can have two things, either G, that is G for gravel, or S for sand. Okay, S for sand. Okay, S for sand. Now, if I will repeat this again in detail, just I am giving me a brief overview. Okay, now say if now you decided the soil is coarse. Coarse can be either gravel or it can be either, or it can be sand. Now, if more than, if more than 50% of that amount is passing through 80 mm sieve, then that is sand, and if not, it is gravel. Okay, then it is sand, else it is gravel. For sand, uh, uh, what did, sorry, I said that if more than 50% is passing through 4.75 mm, then that is sand, and if not, then it is gravel. So greater than 4.75 mm, if you have most of the particles, then it is going to be gravel, else it is going to be sand. If less than 4.75 mm, maximum of the soil is having a size of less than 4.75 mm, then it is going to be sand. Okay, so that's how you decide whether the coarse grained soil is gravel or sand. Okay, now you decided the soil is gravel or sand, you already decided that. Now we are going to decide the suffix of that. Suffix, okay, prefix G or S, you already decided. Okay, G, it will be either G or S. Your first half 50% work is done. You decided that it's going to be G or it is going to be S. Okay, now next part is to decide the suffix part. Now the suffix can be, there are various uh, scope that the suffix can have. Okay, suffix can take many values. Now see what is written here. When the fine fraction in a coarse soil, when the fine fraction in a coarse soil, that fine fraction means the amount of soil that will be passing through 75 micron sieve, is less than 55%. When the fine fraction in a coarse soil is less than 5%, we are going to classify on the basis of gradient gradation. Means the suffix can be either well graded or poor, W or P, well graded or poorly graded. Okay, when the fine fraction is very negligible in a soil, the fine fraction is very negligible, the suffix is decided based on whether that coarse grained soil is your what to say, your uh, well graded soil, or either it is a poorly graded soil. Okay, done. Done. Okay. So next, what is fine grained soils are classified using plasticity. So we will see that. So this is called a plasticity chart. So now now forget about coarse grain. Coarse grain you forget. Okay. Coarse grain just a basic you got how to classify the coarse grain thing. Coarse grain soil that you forget. Now coming to fine grain soil. Fine grain soil means most of the particles in that amount of soil, like more than 50%, is passing through 75 microns. Means the size is smaller than 75 microns. Then what we do, then we take help of this chart. Okay, this chart is called the plasticity chart. Okay, so here you can see, here we have the liquid limit and this side we have the plasticity index. Now if the and this line, this particular line is called the A line, and note this equation of A line. Okay, we will need this equation of A line is IP, that is plasticity index, equal to 0.73 WL minus 20. Okay, this equation you must remember. Okay, we will be needing this. Okay, we will be needing this. Remember this equation. Now if our soil plots above the A line, then it is clay, and if it plots below the clay line, below the A line, it's going to be silt. Okay, so above the A line we will be having clay, and here we will be having silt. Okay, above the A line it's clay, below we are going to have silt. And if the soil falls in this particular region, see between 4 and 7 part, here you can see this part, this shaded part, then we have to use dual classification, CLML. Okay, CLML. So we will see all these things. Okay, when we do, the things will get more clear and clear. Okay. Okay, now see, now again coming back to our coarse grained soil. When fine fraction in a coarse soil, that is when the percentage of soil passing through 0.05 mm sieve is greater than 12%, classify as GM or SM if the soil plots below the A line, or GC or SC if the soil plots above the A line. So if the fine fraction in our coarse soil is less than 5%, then we will be assigning it either well graded or poorly graded. Okay, that we already discussed. Now if the fine fraction is greater than 12%, then the suffix will be decided based on whether that fine fraction in that coarse soil is clay or silt. Okay, so that suffix will be now M or C. All right. Okay, so this might seem a little bit confusing, but when we do one by one, when you solve the problems together, that it will be crystal clear. Okay. Now, when fine fraction in a coarse soil is between 5, so below 5%, it will be GW, GP, or SWSP. If the fine fraction is greater than 12%, it will be GCGM or SMSP, SMSC. Okay, GC, GM, SM, or SC. Right. Now if the fine fraction is between 5 and 12%, then what we have to do, we have no option, we have to go for dual classification. It is such as SWSC, well graded sand, well graded sand, clayey sand, like that, dual, or well graded, poorly graded sand, clayey sand, like that, something like that. So dual classification, for the one example it is given. So dual classification we can have. Okay. Okay, now the question is, can fine grained soils have dual symbol? So this was about coarse grained soil, right? So now tell me, can fine grained soil have dual symbol? Can fine grained soil, clay or silt, mean most of the soil is clay or silt. Okay, forget about coarse grain. Can fine grained soil have dual symbol? Yes or no? Can fine grained soil have or have not dual symbols?
Of course, it can have soil.
Yeah, it
Uh,
can have, right? Yeah. So give one
it can
example.
have CL inverse,
Yeah, correct. CL
inverse
inverse. So
CL.
we, yeah. So we just discussed, right? It can have fine grained soil, can have dual symbols. Okay. So some examples of that I have given here. Possible dual symbols of fine grained soil: CLML, CIMI, CHMH, MLMI, MIMH. So this CIMI, CHMH, MLMI, those will be happening when, say, When, so say this is the plasticity chart, this is IP, we have liquid limit here. Okay, this is the A line. Okay, this is 35% line, this is 50% line. Now say the soil is here, both of the soil is plotting very close in this part where I've given this, mark this, very close to a line, then it's going to have CLML, CIMI1 here, and CHMH1 here. Okay, now next is MLMI. When can it have MLMI? MLMI it can have when it's here, very close to this vertical line. MIMH when it's going to be here, CICH when here, and C CLCI when here, and CLCH when here. Okay, when they are very close to the boundaries, very close to the boundaries, at that time we have to go for our dual classification. Okay, we have no option, but we have to go for dual classification. Now I will write the steps of soil classification. Just give me 1 second. First, what we need to do, we need to get the grain size distribution chart. How can we get that? You can get that by from sieve analysis, right? So first we need to get the GST, grain size distribution. Now, if greater than 50% retained on 75 microns, then what is the soil? Is greater than 50% of the soil by weight is retained on 75 microns, then what is the soil? Coarse or fine? The soil is coarse or fine? If greater than 50% is retained on 75 microns, what is the soil? Is it coarse or is it fine? Hmm? If more than 50% is retained on 75 microns, then tell me the soil is coarse or the soil is fine?
Then the soil is coarse grained, sir.
Yeah, it is coarse grained, right? So it is a coarse grained soil.
Sir, I have one doubt, sir.
Yeah.
Sir, while doing the plastic limit, I'm getting the value like 13, like 25.6,
Uh,
right?
uh.
Should I report the plastic limit value as 26 or 25.6? So can plastic limit have that fraction value in terms of percentage?
Yeah, 25
Yes,
points.
I'm
Yeah.
having that
What
doubt.
what what is the doubt?
Sir, while doing the plastic limit, I'm getting the value like 25.4, sir, right?
So you report 25.4 itself. What is the issue?
No. Actually, we are doing consultancy. That's why I'm asking.
Oh,
While
okay.
reporting to the consultant, yes.
What is the criteria? What are they telling? Like
Should I report the plastic limit in like fractions or like the decimal values, or should I report the value as an integer?
no,
That's my question.
you can report as a decimal value. That is not an issue, because liquid limit, when you take out from the this liquid limit and plastic limit, when you calculate, those can have fraction values, right?
Yeah, so that can have the fractions value, but I didn't see any report with a
Yeah, generally,
decimal
yeah,
value.
yeah.
That's why I'm
That's
asking this
because
question.
generally say when someone calculates a liquid limit also, they are only they decide to round it off, right? So
Mm, mm,
just
mm,
for
mm.
yeah, that's the thing. That's why when they calculate, even when they are calculating liquid limit and plastic limit, just they round it off, say 20 and 20 percent or 21%, say you are getting liquid limit, and plastic limit say you are getting 10%, so 10.5%, so maybe they round it to 11% or 10%. So it's based upon the normal engineering judgment only. Now it won't make that much difference, right? So yeah, so generally that's why people just round it off. Yeah, there is nothing. Yeah, it's up to your choice. There is nothing much. No, nothing technical here. Yeah, it's up to your
Okay,
choice.
thank you.
Yeah, 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 yeah. Because when you are you doing the this liquid limit and plastic limit test, those are very like what to say, not very accurate tests, right? You can see because you are making some paste of the soil, then plastic limit, moreover you have to roll the 3 mm, and how do you decide that the point which, say, there might be, you understand, right? So you, plastic limit test, what you need to make some a 3 mm thread of the soil, and you would have to just identify where it
Mhm.
just starts to break. Those things are very like abstract, right? There is a scope of adjustment. Understand, right? So that's why people tend to round it off generally. So it won't make much of a difference. If you write 25.5, if you are getting, if you whether you write it at as 26 or you write just 25, it's not going to make a lot of difference. It's up to you. But you can report it on decimals. But generally, people don't prefer just for the sake, because it's not going to make much of a difference as long as you are not working with the borderline values. Okay, that's the thing.
Okay, sir.
Yeah, yeah,
Thank you.
yeah, yeah. So yeah, so this one we decided that this soil is coarse. So coarse means what? What are the prefixes it can have? What are the prefixes it can have if the soil is coarse?
G or S.
Yeah, G. It can have G or it can have S, right? So when G,
If the soil particles retained on 4.75 mm see more than 50%, then it is
correct, correct.
gravel.
If more than 50% retained on 4.75 mm, then it's gravel. And if greater than 50% passes 4.75 mm, then it's sand. Okay. Now, now soil is coarse, we decided, right? The soil is coarse. Now, if the fine fraction in this coarse soil, if fine fraction is less than 5%, okay, then what can be our suffix now? So prefix you already decided, right? Prefix you decided, it can be G or S. Now based, we have to decide the suffix. So if fine fraction in that soil is less than 5%, so what are the possible suffixes you can have?
It could have either clay or silt, C or M.
No, less, fine fraction is less than 5% in this
Oh,
course.
then
Yeah.
it would be well graded or poorly graded, right?
Yeah,
We have to do the
yeah,
gradation.
W, yeah, W or P, right? Greater than 12%, then C, S or M, C or M, right? And between 5 to 12%, we will have dual classification. Okay. Now, now coming to our this fine grained soil. So when fine grained soil greater than 50% passing 75 micron. So we have, now our suffix is prefix is either C or M, right? So this will be either C or M. Now this second part I have to decide. Now, how do you decide the suffix? How do you define the define the suffix now? Decide the suffix now.
It's based
What?
on the configuration limit.
Yeah, correct. Based on the liquid limit, right? Based on the liquid limit. So if the liquid limit is less than 35%, then it's going to be I. 35 to 50, it's going to be AM. Sorry, it's going to be L. It's going to be I. Greater than 50, it's going to be I. Right? Okay. Now, going to this. So okay, this. So this classification, this much was whatever was discussed. We will solve the problems based on classification only. At that time, it will be more. Everything will be more clear. Okay. Just before we go to the problems, let us see this part just for the sake of completion. What are soil structures? Soil structures are mode of arrangement of soil particles plus the forces between them that hold them together. So in coarse grained soil, since the particles are quite big, so gravity is the force that holds the soil particles together in a coarse grained soil. Whereas in fine grained soil, such as clay and silt, the size of the particle is very small. So the specific surface is very high. What is specific surface? The ratio of surface area to the material its mass volume. So specific surface will be higher when the particle sizes are very small. So if the particle sizes are small, that is in fine grained soil, what is going to happen? The electrical charges or all those things, the chemical behavior that is going to be the main force that holds the particles together and not the gravity. Okay. So clay surface, so specific surface determines which is dominant, whether it is gravity or surface bonding forces. If specific surface is higher, then means surface bonding forces will be dominant. Clay soil are made up of clay minerals, which has plasticity and cohesion that we already know. We all know from our basic judgment. Clay minerals are electrochemically active. Now, clay minerals are divided into three basic groups based on their crystalline arrangement. One is kaolin, then we have montmorillonite, and then we have elite. Okay, so these are various clay minerals
Sir,
which form the clay particles. Yeah.
sir, again, I'm having some doubts. So, like, we have a clay minerals like halloysite, pegmatite, serpentinite. So those are
What?
the
What?
clay. They are also the clay minerals.
What? 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 I didn't get you.
Sir, regarding this clay minerals, I referred a
Uh
book.
huh.
In that, they mentioned like some of the other clay minerals like halloysite, pegmatite,
Yeah. Yeah.
but
Yeah. Yeah.
no book mentioned. Yes, that's my question.
Yeah.
Why they are not mentioning those clay
I
minerals,
think
those
because
minerals
those,
as minerals?
yeah. Because I think that this kaolin, montmorillonite, and elite, these are the majority. What forms the majority of the clay mineral. That's why most of us focus in this only. Kaolin, montmorillonite, and elite. These are, we consider this as the basic three constituting clay minerals. There can be other clay minerals also based upon the chemical composition, but those will be like what to say very specific cases. Okay, generally whatever soil we take, it will have this either kaolin, montmorillonite, or elite. Okay, so that's why probably we just go decide group this in these three main groups: kaolin, montmorillonite, and elite. Okay, we can have other clay minerals also. Okay, because based upon the chemical composition we may have, but generally in general we have these three. That's why most of the textbooks also refer to these three main clay minerals. Okay, else nothing else, nothing. So these clay minerals are what? These clay minerals are made up of what? Some basic fundamental crystal sheets. So crystal sheets from the clay minerals, then the clay minerals from the clay particles. So this is the small to higher size I'm doing. So first we have the crystal sheets. These crystal sheets, they form the clay minerals. Then these clay minerals come together to form the clay particle. Okay. So the crystal sheets are can be the tetrahedral sheet or the octahedral sheet. The tetrahedral sheet is the silica sheet, that is also called the silica sheet. The octahedral sheet is called the alumina sheet because it has aluminum ion in it, and the tetrahedral sheet is called a silica sheet because it is a silicon ion in it. Okay. Yeah. Now in silica sheet, we have like this some arrangement. Okay, we have four oxygen outside. Okay, and the center we have one silica. Okay, this is how the tetrahedral silica sheet actually looks like. And in the octahedral sheet we have six OH minus ions. Okay, and then we can have two types of metal ions in them. If we have aluminium ion, then it is called gypsite, or, and if we have magnesium ion, It is called uh, box. I forgot the name. Okay, just check it once. I forgot. Okay, box. Burite or something like that. Okay, check this name. I don't. I cannot recall. Okay, then what is isomorphous substitution? In clay mineral lattice, metallic ions may be substituted by other metallic ions having lower valence but similar size. That is known as isomorphous substitution. So, in a clay mineral, say we have a silicon atom in it, silicon ion in it. Say silicon get replaced by another ion of the same size. The size of the ion is same, physical size is same, but can have the valence of the, say it can be have 2 minus or it can have 1 plus, so that valence might vary but the size is same, so that is known as isomorphous substitution. Now coming to the clay minerals, so first we have the this kaolin. So in kaolinite, what we have one gypsite sheet, then we have one silica sheet. Okay, then we have again here we have one more gypsite sheet, then we have one silica sheet. Okay, like this the the arrangement continues, and in between here there is hydrogen bond. Okay, so since we have hydrogen bond, as you know, hydrogen bond is the strongest bond. So if we have hydrogen bond, it makes that type of clay least reactive. Okay, least active because of the hydrogen bond. Okay, it does not absorb water or anything. The bond is very strong and least reactive. Alright. Then we have Montmorillonite. In Montmorillonite, the arrangement is something like this. We have silica, we have gypsite, we have silica like this, and again opposite side like this, like this, like this, and it continues. Okay. So in this, the bonding is weak van der Waals bond. Okay, since the bond is very weak, any external agent comes and disturbs that kind of soil. So the most common external agent is water, nothing but water. So as soon as water comes in contact with Montmorillonite, what happens? It starts absorbing water and begins to expand. Okay, so this type of clay soil that is formed of Montmorillonite are known as expansive soils. Expansive soils are those soils which absorb water and then undergo rapid or huge amount of volume change, volume expansion, volume increase. Okay, so this makes this type of clay or this type of soil very dangerous. So say in some place you have uh, mm, uh, Montmorillonite clay soil which is composed of Montmorillonite. Okay, in that place you cannot construct anything, because as soon as you construct some road or some building, whatever you want to construct, you say in dry season it's fine. Okay, if the season is winter, it's dry. Okay, you can construct it. Now as soon as you have the monsoons coming, rain is going to pour. As soon as the soil comes in contact with water, it's going to expand by huge amounts of volume, and due to that expansion there are going to be differential settlements and everything, and the structure is going to fail. Okay, so that's why this Montmorillonite is very risky. We have to avoid this kind of expansive soil. Now the most common type of expansive soil that is found in India is black cotton soil. Why black cotton soil? Because the soil looks little bit blackish, and the cotton is grown, good amount of like cotton grows on this soil. Okay, that's why it's known as black cotton soil. So these type of soils are very risky for any type of construction. So what happens, as I said, these bonds are weak, so water comes interacts, a lot of amount of water is absorbed between these bonds. Okay, that's why the soil expands. So I heard of a project where a um, railway project. So railway track was to be constructed in somewhere. So what happened, they encountered black cotton soil in that place over a stretch of land. So finally, what they decided was that to completely excavate completely, so to whatever depth that soil, black cotton soil was there, say 5 meter or 6 meter, whatever, so decided that they will excavate out that whole amount of soil in that part, and then they will fill that part with other better granular soil like sand, and they will compact it, and then over that they will construct, do the construction. So that's why you have to avoid this black cotton soil. You cannot construct anything like that. If you construct a road over it, it's going to have cracks, it's going to fail. Similarly, obviously you cannot construct buildings, it's going to have differential settlements, it's going to fail. Okay, it's very risky kind of soil. Obviously, say if you have like, there are many other things, I won't go into detail, but this is the basic thing. Okay. And finally we have the elite. So elite is more stable, more less stable than kaolin, but more stable than montmorillonite. It has the same arrangement as this montmorillonite, but here uh, what happens in the bond, here we have this potassium ions here. Okay, potassium ions, which makes it little bit stable. Okay, it makes it little bit stable. Okay, just let me check what's there. Yeah. Okay, now clay particle interaction. So if you remember, we had discussed in the previous class about this, what to say, this hydrometer test. Okay, hydrometer test, we recalled that what happens, we have to put some dispersing agent, and then also we have to use distilled water. So why you have to use? Because in aqueous, see it's written here, in aqueous environment clay particles generally it flocculates, so flocculate or disperse. So if it disperses, there is no issue, but if it flocculates, means if the particles come close to each other and stick to each other, it is going to be an issue. Okay, so we have to avoid that during our hydrometer. That's why you use distilled water and then dispersing agent. So flocculation mostly occurs in the H2 phase configuration. Say we have one particle here, have the particle here. So like this, generally flocculation happens, and dispersion generally happens like this, phase to phase. Okay, phase to phase. Like this, the particles are going to separate out. Okay. Okay, so that was all about this basic theory. Okay, now let us just start solving the problem. So there are not many, very less number of problems. So, but I want you to do this yourselves. Okay, I will be helping very less because it's very easy and you should be able to do it. And that way, all your doubts also should be clear. Okay, let us see. So first question is, from the grain size distribution data given, classify the coarse soil. Okay, so try to do this and tell me what kind of soil it is. Try to do this. I will give you 2 minutes first to try yourselves. From the grain size distribution data given, classify the soil.
It is, I think, SP.
Now S what?
SP.
SP means poorly graded
Yes,
sand.
yes, sir.
Okay, okay, we'll see. Okay, others,
D50 is
anyone?
0.48, D10 is 0.21, and the CU is upper is 2.28. It's not greater than 6. So you can consider that poorly graded. And
Okay,
since most of the particles are less than 4.75 mmC, so yes, you can say that. Yes, it didn't mention about the 75 micron, right?
okay, okay, right. So you said SP, right? Yeah. So first we know that the soil is coarse, right? Soil is coarse, so it is either going to be gravel or it's going to be sand. Now, how to decide whether it is a sand or gravel? How did you decide that it was sand or gravel? Because more than 50% is finer than what? 0.48, like more than 50% will be finer than 4.75 also. If it's 60% is finer than 4.48, means obviously 60% is all, means obviously more than 60% is going to be finer than 4.75 mm. Right, all of this fraction is finer than 4.75 mm. So first we decided it is sand. Okay, then we have to decide whether it's a well graded or poorly graded. So for that you have to find out coefficient of uniformity and coefficient of curvature, cu and c. What is cu? D60 by D10. What is D60? D60 is nothing but 0.48. D10 0.21. It's 2.28. Now 2.28. Okay. Now CC D30 square by D60 into D10, 0.33. 0. Now we know for a soil to be, for a sandy soil to be well graded, the cu should be greater than 6, but here you can see the cu is not greater than 6, though the cc lies between 1 and 3, but the cu is not greater than 6. So that's why, what did you call, we are calling this soil is a poorly graded sand. Okay, so this is how we classify it. Okay, good, very good. Okay. Now next, now do this. From the sieve analysis data given, classify the soil given the size of the aggregates very linearly and the fine fraction is non-plastic. Okay, try to do this.
It's going to have that Dewey classification. So since it's a non-plastic, I think that sand is confirmed and um,
Sand
25
is
micron.
confirmed, right? Sand is confirmed because more than
Yes,
50% is passing through 4.75. Okay.
yes.
Yeah.
It is going to have Dewey classification. So yes,
And
I'm
then
going to come and uh, mm,
okay, take your time. Do like take your time and do. There is no hurry. We have lots of time. So first thing we decided that the soil is definitely sand. Okay, so 50% of our work is done. Okay, so first thing you have to decide that whether the soil is fine grained soil or coarse grained soil. So less than 50%, like more than 50% is retained on 75 micron sieve, 0.05 mm sieve. So definitely the soil is coarse grain, right? Because percentage finer than 0.075 is only 7%. Okay, most of the soil size is, particle size is greater than 0.075 mm, right? So that's why first we decided the soil is coarse soil. Done. First thing done, first job is done. We decided the soil is coarse soil. How did we decide the soil is coarse soil? Because more than 50% is retained on the 75 micron sieve, or the percentage finer than 75 microns is less than 50%. So that's why we decided that the soil is coarse grained soil. Now next task is to identify whether the coarse grained soil is sand or gravel. Now definitely more than 50% is passing through 4.75 mm. More than 50% is passing through 4.75 mm. So it's definitely going to be sand. Definitely it's going to be sand. So two of the things are done. First we identified coarse, the soil is coarse soil. Then we identified that the soil is what kind of coarse soil? Sandy coarse soil. Now next part we have to do. Try. See, first, what did you do? Percent finer than 0.075 mm is less than 50%. So our soil is coarse. Now what type of coarse? Percentage finer than 4.75 mm is greater than 50%. That is sand. So S is decided. Now next part you have to decide. Now since fine fraction fine fraction means the fraction having size less than 75 microns. Fine fraction is 7%. That is between 5 and 12%. The fine fraction is between 5 and 12%. Since fine fraction between 5 12% is 7%, we'll have dual classification. Okay, we'll have dual classification. Okay, now let us first try to decide whether the soil is will will have what are the possible dual classifications that we can have. The possible dual classifications are what? SW, SM, SW, SC, SP, SM, SP, SC. So these are the possible dual classifications that we can have. Now let's first concentrate on this part first. Whether it's poorly graded, whether it's well graded. Now we have to find out the D60 and the D10 size, right? D60, D10 and what? The D30 also we did, right? So D30 size. So these three we need: D60, D10 and D30 size. These three we need. Now see, in the question it's given the size of the aggregates very linearly, means the size distribution is linear. So what we can do, we can interpolate the values. So 80 minus 7 by from here we will get D60s 3.47 mm. Similarly again we will interpolate for D30 because it's given in the question that the aggregate very linearly. That's why we are doing this. Okay. Okay, and finally similarly for D10 also we will do. Now find the CU&CC. Now calculate the CU&CC. So this is greater than 6 and this is between 1 and 3. So definitely the soil is well graded, right? So W also we decided. Okay, the soil is well graded. So the first half is decided. That is the soil is well graded. Okay, it's definitely SW. Okay, now decide the second part. Now tell me what's the trick here in the question. Some hint is given in the question. You should be able to identify. Tell me whether it will be C or M. You should be able to tell me. We have already discussed everything. Everything is given in the question. The answer is there in the question itself. Whether it's M or C. Silt, right? Why silt? Why silt? Why silt? Why did we decide it as silt? Yes, correct, correct. Because it's non-plastic. Right, very good. Because it's non-plastic, we decided that the soil is silt. Okay. Alright, from the sieve analysis data given, classify the soil. Given total weight of the sample used in the sieve analysis is 500 grams. So do this. Do this sieve analysis that data is given. See how we can classify. Try to do this. Try to do. First, try to find out the percentage finer for each size. Try to calculate the percentage finer. So we have sieve size, we have weight retained, we have percentage weight retained, we have percentage cumulative weight retained, we have percent finer. Okay, try to do this. So sieve size 0.6, 0.5, 0.425. Weight retained is 200, 250, 50. Percentage weight retained 200 by 500. How much? Into 100%. 40%. Now 250 by 500, 50%. And 50 by 500, nothing but 10%. Cumulative weight retained 40, 40 plus 50, 10, 100 is the cumulative weight retained. Right, the percentage finer 100 minus this 60, 10, 0. Now already you can see that the soil is mm, sand, right? Because 4.75 small size fraction having sizes smaller than 4.75 is the whole fraction. The whole fraction is size smaller than 4.75 but 0% of the soil is having a size less than 0.425. That means obviously 0% of the soil is having size less than 0.075 That means the soil is perfectly coarse and the soil is sand. Okay, the soil is sand. That you decided. Now what we have to calculate? We have to calculate the CU, coefficient of uniformity. What is that? D60 by D10. It is D60 0.6. What is D10? 0.5. It's what? 1.2. It is not greater than 6. So definitely the soil is poorly graded. So it's nothing but SP, poorly graded sand. Poorly graded sand. Okay. So how did we decide that the soil is coarse? Because 0% of the soil is passing through 0.075 micron. Sorry, 0.75 mm, 75 micron. How? Because only see 0% is passing through 0.425. So obviously 0% is passing through 0.075. That means the soil is coarse. As the soil is coarse, soil is obviously sand, because 100% is smaller than 4, see, uh, 4.75 mm. So obviously the soil is coarse. Now soil is sand. Now sand, we decided, next you have to decide whether it's well graded or poorly graded. For that what we do? For that we calculate the CU, and CU is definitely not greater than 6, so that's why we decided the soil is poorly graded. Okay. Okay, very simple. Now try to do this. From the sieve analysis data given, classify the soil given the total weight of the sample given in sieve analysis is 1000 grams, that is 1 kg. Liquid limit is given and plastic limit is also given. Okay, so try to do this. First tell me whether this soil is coarse grained soil or whether it is a fine grained soil. Tell me this. Tell me whether the soil is a coarse grained soil or the soil is a fine grained soil. See, let us just again make this table. F 20 gram, 20 by 1000 is 2%, and this is 73%. Cumulative weight retained is nothing but 2%, 74%, percent finer 98%, and 25%. Now less than 50% is finer than 0.075. That means the soil is coarse soil. Sand, definitely sand, because 98% is passing through 4.7. 98% is finer. 98% of the soil is finer than 4.75 mm. Definitely the soil is a coarse sand soil. And why it is not a fine soil? Because less than 50% is finer than 75 microns. That means the soil is definitely sand, right? Sand. Now what is the percent of fine fraction in this coarse soil? What is the percentage of fine fraction in this coarse soil? The percentage of fine fraction in this coarse soil is 25%, because 25% is less than 75 microns, that is 25% is the percent of fine fraction in this coarse soil. Now 25% is greater than 12%, that means our suffix is going to be either C or M, either clay or silt. which we will be deciding based on the given values of liquid limit and plastic limit. Okay, so our prefix is definitely sand. Now for the suffix, it's going to be either clay or it's either going to, or it's going to be silt. Now definitely, to decide that, we have to make use of the plasticity chart given here, plasticity chart, and for that the values of liquid limit and plastic limit are also given to us. Now, what is the plasticity index of the soil? Please tell me, what is the plasticity index of the soil? What is the plasticity index of the soil? What is the plasticity index? Yeah, 22. 40 minus 18. Good. 40 minus 18. That is 22%. Very good. Now, what is the equation? What is the equation of the A line? 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 Equation of the A line is plasticity index equal to 0. A line means this line. It's written here 0.73 liquid limit minus 20. That means what? 0.73 40 minus 20. So what is it? How much is this one? Calculate. Yeah, calculate this one. Whatever I have written. Right, you are right. 0.73 liquid limit minus 20%. Now calculate this. Calculate what is the value of plasticity index that you are getting from this equation. What is the value of plasticity index corresponding to a liquid limit of 40% on the A line? What is the value of plasticity index corresponding to the liquid limit on the A line? Just put liquid limit 40 here and do calculate this. Do this 0.73 40 minus 20. How much is it going to come? 14.6. Right, 14.6. Now tell me, you have the plasticity index of your soil. Now you calculated the plasticity index on the A line. Now it is 14.6. Now tell me whether the soil is clay or silt. Clayey or silty? Tell me whether the soil is clayey or silty. With the, now whatever you have done with the available data, you should be able to tell me whether the soil is clay or whether the soil is clayey or whether the soil is silty. See, our plasticity index is 22. 22 is greater than 14.6, isn't it? 22 is greater than 14.6. That means our soil is plotting over the A line, above the A line. Right, soil is plotting above the line. Where is it plotting? Liquid limit is 40 and it's around so it's somewhere here it will plot. So definitely the soil is what? Clay or silt? It's greater than a 14.6. That means it's above the A line. Now if the soil is above the A line, what is it? Clay or silty? It's above the A line means what? Clay or silty? Above the A line means correct. Good. Above the A line means clay. So what is going to be my final classification of the soil? Please tell me. Final classification of the soil. Final soil classification of the complete soil. What is it? Join the prefixes and suffixes, suffix together. What is going to be? What is it going to be? Clayey sand. SC. Right. This is going to be the final answer. SC. How will you call this? Clayey sand. Okay, clayey sand. Okay. Now next, similar problem. Classify a clay soil. It's already given in the question. Already given in the question that the soil is clay. That means the prefix is already decided, clay. The suffix you need to decide. To this, tell me what is going to be the suffix of this clay soil. It's already told that the soil is a fine grained soil and it is a clay soil. So the prefix is given to you. The suffix you need to decide. Tell me what is the suffix. Tell me. Very easy. Tell me. What's going to be the this suffix? What's going to be the suffix? Say clay, or it is given in the question. It's clay, clay soil. Just you need to decide the suffix. No, clay. See, you have already decided. I am clay. Yeah, right. I am asking about the suffix. Second part. What kind of clay? Clay is given in the question already. It's clay. What clay? Now the soil is majorly clay soil. Before we are discussing the problems that we solved, that were what? Coarse grained soil. Now come to think about the fine grained soil classification. Clay, we know it's clay. What clay? What clay? See, before what we did, don't get confused. Okay, don't get confused. Before what we did, these were the classification of coarse type of soil. Okay, coarse soil. Coarse soil. Now here, this question is about fine grained soil, where more than 50% of the soil is finer than 75 microns. That time, how do you classify the soil? So you already given in the question, it's clay, right? You need to decide the suffix of it. Prefix C, decide it. Suffix you need to decide. Very easy, straightforward. Liquid limit is given 40%, right? Liquid limit is given 40%. The 40% is what? Between 35 and 50%. So if the liquid limit is between 35 and 40%, what type of clay will it be? Already it's written in the chart, plasticity chart. It's going to be CI, right? CI is going to be intermediate plastic clay. CI. CI. Okay, so the classification of the soil will be CI. Okay, now let us come to the next question. Classify a soil sample if it has a liquid limit of 40%, plastic limit of 30%. The percentage passing through 4.75 mm is 65%, and that through 0.075 mm is 58%. First tell me whether the soil is a fine grained soil or is it a coarse grained soil. Tell me whether the soil is a fine grained soil or a coarse grained soil. First major group you have to decide, right? Whether it is a fine grained soil or it is a coarse grained soil. What is it? Hmm? Whether it is a fine grained soil or coarse grained. How do you decide whether the soil is a fine grained soil or coarse grained soil? If more than 50% of the more than 50% is finer, more than 50% is finer than 0.075 mm, then the soil is a fine grained soil. And if more than 50% is finer than is greater, coarser than 75 microns, then it is a coarse grained soil. Now tell me whether this soil is a fine grained soil or coarse grained soil. See, the percentage passing through 4.75 mm means 65%. Just if you read this line, you might think that is it might be sand. But next, come to the next, and that through 0.075 mm is 58%. That means what? More than 55% is passing through 75 micron sieve. That means more than 50% sizes are smaller than 75 microns. That means majorly the soil is a fine grained soil. That means the prefix will be either C or it will be M, clay or M, C or M. It will be either C or it will be M. Alright, or it might be O also. OI also. O means organic. It will be organic. You can identify the soil with a distinct smell of the odor of the soil. Okay, and color will be blackish color. Will have odor. That's how you can identify. So it can be either clay or silt or organic clay, whatever. Definitely, it is a fine grained soil. Now, tell me the plasticity index of the soil. What is the plasticity index of this soil? PI. What is the plasticity index of the soil? 10 means 40 minus 30, 10%. Now plasticity index calculated from the A line. Tell me the plasticity index calculated from the A line to this. Again 14.6. Now 10% is less than 14.6%. That means what? That means what? That means the soil is plotting below the A line. If the soil plots below the A line, what are the possible options? The soil will be what? Clayey or silty. If the soil plots below the A line, then it will definitely be what? Correct, silty. So M, you have decided the prefix part. Now decide the suffix part. What will be the suffix? Prefix you decided M, correct, silty. You are correct. Now decide the suffix part also. Same, similar to previous problem. Decide the suffix part. No, silt is fine. You are correct. Suffix, the second part of the classification, that you decide. Silty, you are right. Prefix, you are right. It's silty. Suffix. Again, same. Liquid limit is what? 40%. Between 35 and 50%. So it will be I. Right. I am I. So again, see here. O's are also possible. So Mi, or it can be Oi also. Okay, so don't get confused about it. If you write even write Mi, it's going to be fine. Mi, okay, it's going to be Mi or Oi, whatever. Y means that is organic. Thing else. Okay, now do this. Classify a soil again. Do this. Forget about this part now. Just try to first tell me this soil is what? Coarse grained soil or fine grained soil? First decide this. The soil is coarse grained soil or the soil is fine grained soil? Soil is coarse grained soil or fine grained soils? Yeah, right. Correct. It's fine. Correct. Why is it fine? It's fine because more than 50% is passing through 0.075 mm. So it's a fine grained soil. So fine grained soil, really C or M or say O, whatever. Okay, that you decide. Prefix C or M or O. Now what will it be? Calculate same. Calculate plasticity index 30%. Plasticity index from A line you calculate. Oh, sorry, plasticity index is 10%, right? Sorry, huh? Just a second. So plasticity index is given 10%. Huh? Before plasticity, here plasticity index is given directly 10%. Now see, the plasticity index is less than 14.6%. That means what? It's plotting below the A line. Now, if it's below the A line, it will be what? Either M or O. Now, how to decide whether it is M or O? For that, you can see one additional information is given to you. I have given to you here. If the liquid limit of overnight sample is less than 3/4 of its in situ soil sample, then the soil is organic, else inorganic. Now, what is the liquid limit of overnight sample? It's 25%. Okay. Now, what is 3/4 of the liquid limit of the in situ sample? Means 3/4 of 30. So 25% is definitely less than this. That means our soil is O, organic. Now again, next I have to decide the suffix part. The suffix parts, how I will decide? Same, liquid limit 40%, though it will be I, intermediate. Done. Okay. Now do this. Try this by yourself. You should be able to do. You have solved enough. The last three problems are this one you should be able to do. Try to do this. Classify a soil sample if it has a liquid limit of 35%, plastic limit of 20%, the percentage passing through 0.05 mm is 20%, and the percentage retained on 4.75 mm is 60%. Try to do this. First decide First decide whether the soil is fine grained soil or whether it is a coarse grained soil, and tell me that whether the soil is a fine grained soil or whether it is a coarse grained soil. Coarse grained soil, right? Correct. Very good. Very good. Because more than 50% is greater than, more than 50% is greater than what? More than 50% is greater than 0.075 mm, right? So that's why we are telling that the soil is coarse grained soil. First thing you have done. A second thing, you decide whether the soil, you have already decided the soil is coarse grained soil, right? Now you decide whether the soil is which kind of coarse grained soil, sand or gravel, that you decide. You have to decide whether it is a sand or it is a gravel. Decide whether it is a sand or it is a gravel. You're right, it is a coarse grained soil, but now you have to decide whether it is sand or it is gravel. Decide that. Whether it is, what is the criteria for a soil to be sand or gravel? Think about that. The size. Tell me whether it is sand or gravel. See, the percentage retained on 4.75 mm is 60%. That means what? More than 50% is retained on 4.75 mm. Retained means more than 50%, 60% of the size is greater than 4.75 mm. That means the soil is gravel, right? The soil is gravel, G. Okay, so the prefix will be nothing but G. Now you need to decide the suffix. How will you decide the suffix? What are the possible suffixes that you can have? Tell me. Tell me first this one. What are the possible things you can have? How to decide the suffix now? Prefix, it is gravel, right? This is gravel. How do you decide the suffix now? Gravel is fine, but see, it could be either no. Well, you are saying to define based on the gradation. Suffix to be defined on the base of the gradation. We are saying that gradation. But see, for that, the fine content, the fine fraction in this gravel soil should be less than 5%. Only then you can decide based on the gradation, well graded, poorly graded, all those things. Okay, if the fine fraction in a coarse soil is less than 5%, only then you can decide based on the gradation. But here, the fine fraction is how much? What is the fine fraction here? What is the fine fraction here? 20%. Means more than 12%. 20%, which is more than 12%, is more than 12% of the fraction in the soil is fine fraction. Okay, then we have to decide based on whether the suffixes can be either C or M. So here the fine fraction is what? 20%. So it's greater than 12%. So it will be either GC or GM. Now decide whether it is GC or GM. This you do. You decide whether it is GC or if it's GM. That you do. You do decide whether it is GC or GM. If it is GC or GM, same, use the whatever you did in the previous one. How did you decide whether it is a clay or silt? How did you decide that if it's a clay or silk? Same, whether it's putting above or below the A line, you do that. So what is the plasticity index? Liquid limit plus plastic limit, 35 minus 20, 15%. Right, now what is the plasticity index from the A line? 35 minus what, 20, yeah. How much is it? 0.73. 35 minus 20, 10.95. That means 15 is greater than 10.95. That means what? C or M? GC or GM? GC or GM? GC or GM? Above the A line. Above the A line means clay, so GC. This is going to be the final answer. Clay gravel. Yes, correct. GC. Clay gravel. Clay gravel. Correct. Okay. Now try to do this. This is important problem. Very critical problem. Okay. Try to do this. Classify a soil sample if it has the following properties. Percentage passing 4.75 mm is 98.5%. Percentage passing 0.05 mm is 35%. D60, D30, D10 is given. Liquid limit is given. Plastic limit is given. First decide whether the soil is a fine grained soil or coarse grained soil. That you tell me. Fine grained soil or the coarse grained soil? Are you sure? Are you sure it's fine? Are you sure it's fine? How are you calling it as a fine soil? How are you calling it fine soil? Hmm? See, percent finer than what? Percent finer than 0.05 mm should be 35 more than 50%, right? But here percent passing, percent finer than 0.05 mm is the 35%. If percent passing 0.075 mm is more than 50%, then it is a fine soil, isn't it? Here it's just how much? Here it is a 35%. 35% is great. Percent finer is the 35%. Percent finer for 75 micron is 35%. It should be greater than what? 50%. So it's not a fine soil. It's a coarse soil. And definitely it is a sand because 98.5% is passing through 4.75. So definitely it's a sand. Now, now, now since 35% is the fine fraction, means it's greater than 12%. It is greater than 12%. So it definitely should be either SC or it can be SM. Now it's our task to decide whether it's SC or it's SM. Okay. Now see. What is the plasticity index? So these are all just given to confuse you with the question. Okay. 3%. The plasticity index. See. Plasticity index is how much? 3%. Plasticity index is 3%. Now if you see here, this 3% falls between this 4 and 7. What is the liquid limit? Liquid limit is 20. Okay, the liquid limit is how much? 22. That means the soil is the plasticity index is 3% and the liquid limit is 22. That means somewhere our soil is going to plot here in this shaded region of the plasticity index plasticity chart. That means what? That means we need to use dual classification. Dual classification means what? It will be SC SN. Okay, so this is very important, very critical problem. Not that straightforward. You need to see this also. Since the plasticity index is very small, between 4 and 7, you need to have dual classification. So silty sand, clay sand. Okay, doubtful case, borderline case. Okay. Okay, then we will do this last problem. Last class, previous class, someone has asked about this kind of problem, right? So I decided that I will put this problem in today's session. Okay, the problem is determine the base exchange capacity of a clay if 100 gram of dry clay soil absorbs 80 milligram of calcium. Find the quantity of hydrogen that can be absorbed by 5 cubic meters of this clay if the dry unit weight of the clay is 1500 kg per meter cube. Okay, so let me write. Let me first define what is base exchange capacity. So base exchange capacity is ability of clay particles to adsorb ions on its surface or edge. So this is what base exchange capacity is. Base exchange capacity is the ability of clay particles to adsorb ions on its surface or edge. Now, how to find out this, solve this problem? How to determine this base exchange capacity? So, 1 milli equivalent is equal to 1 milligram of H plus. This is the definition of milli equivalent. If you remember from your chemistry classes in class 11th, how do you define 1 milli equivalent? 1 milli equivalent is nothing but 1 milligram of H plus. Now 1 milli equivalent is equivalent to 1 milligram of H plus is equivalent to 40 by 2 milligram of Ca2 plus, since the weight of Ca2 plus is how much? 40 gram. But here we are corresponding to 1 and we are calculating, so 40 by 2 milligram of Ca2 plus. Right, so 1 milli equivalent is equivalent to 1 milligram of H plus, which is nothing but 20 milligram of Ca2 plus. 20 milligram of Ca2 plus. Now it is given in the question 100 gram clay absorbs 80 milligram of Ca2 plus. That means how many milli equivalents? 80 by 20 equal to 4 milli equivalent. So for 100 gram clay, 4 milli equivalent is adsorbed. Right? So for 100 gram, 4 milligram of H plus is adsorbed. Right? So 100 gram, 4 milligram of 100 gram clay adsorbs 4 milligram of H. So 1 kg will adsorb how much? 4 by 100 into 10 minus 3. This much. So 7500 kg. How 7500? 5 cubic meters. So 1500 times 5 meter cube. So this is 7500 kgs. Okay, so 7500 kg is going to absorb equal to 0.3 kg of H. Okay, so 7500 kg kg of this clay is going to absorb 0.3 kg of H. Okay, so this is it. Okay, so this is the end. This is the end of today's session. Please go through these problems of classification very nicely, because now also you are tending to make mistakes, so you are not able to completely understand it. So I suggest that you please solve these problems again and again, once again, so that the basic will be cleared out. So first, the first step is to identify whether the soil is a coarse grained soil or fine grained soil. So if coarse grained, then one way we have to go, then fine grained, then other way you have to go. Okay, then you decide the prefixes, then you go for the suffixes. The suffixes decided based on the fine fraction. If fine fraction is less than 5%, then you will go for, so it depends. As for coarse grained, one way you do, and for the fine grained, so another way. So please do go through this again, once again. Try to solve the problems once again by yourself, and also try to see the lectures, main class lectures also once again. So this will be already uploaded to you. I think the previous class. Did you get the link for the previous sessions? This PDF, everything you got, I think, right? So there again you will get this. Also will be uploaded this video, and this presentation, all everything will be uploaded. Please go through this again and again. Try to solve more and more problems, then I am hopeful that you will be able to answer it yourself, because this is an easy topic, and I think you should be able to answer. Okay, so thank you for so much for attending to this session, and I will be here. We have 6 minutes more, so I will be here till 8, just here. If you have any doubts, you can ask me, else you can leave. Okay, so thank you, have a great day. Okay, I'm here for 5 more minutes, 5 to 6 more minutes, and if you have any doubts, you can ask, else you can leave. Okay. Thank you, Sumedha. Thank you, Sumedha, for attending. Thank you.